How can we develop a Spring REST API with TDD? TDD is an important approach to software development. If you want to work in a software job, you must understand this concept. Today, we are going to utilize the integration testing method for developing a REST API because REST controllers exist in the presentation layer, not in the business layer. We are going to use the TestRestTemplate object for REST communication and mocking methods to simulate the domain layer. Finally, we will use validation to check request fields. First of all, we briefly need to mention our application's expected behavior before we start the implementation. We have 4 main success behaviors and 1 failure behavior. The success behaviors involve CRUD operations. We expect 201 created and 200 OK responses from the server for these operations. When we send a request with null fields, we expect a 400 bad response from the application. This video will not cover exception handling and localization. We will discuss these topics in future videos. Welcome to Tanhu Labs channel. Subscribe to Tanhu Labs for more content. And don't forget to hit the like button. In the previous videos, we developed the service content applications domain and persistence layer from scratch using unit test and integration test. If you want to watch those videos, you can access them using the card at the top of the screen. In the test directory, we need to create a new package named application.create. In this tutorial, we prefer to separate test cases according to their behavior to achieve a highly cohesive test structure. When developing software, we aim to design our system to be loosely coupled and highly cohesive. These are very important concepts in the software design. Similarly, we need to create, delete, read, and update packages for other behaviors and define their respective test classes. Next, create a new Java class named Content Controller Create Operations Test. In this class, we will only define tests related to create behavior. When considering the create behavior, we have 3 basic cases. First, in success scenario, we send a create content request with username and text. We expect a 201 created response with a URL and creation time. In second scenario, we send a create content request with a text and a null username. We expect a 400 batch request response. In third scenario, we send a create content request with a username and a null text field. We expect a 400 batch request response. Now, let's implement these test cases. Firstly, we need to configure our test class for the test suite. Remove the public modifier and add the Spring Boot test annotation with a web environment setting, since we are using TestRestTemplate. Then we need to define our test methods. Should return URL and creation time. When create content request received with username and text. Should return bad response. When create content request received with null username. Should return bad response when create content request received with null text. Now we need to declare a TestRestTemplate instance using the auto-wired annotation. This object will facilitate HTTP communication in our test. Next, we must mock the command handler. Remember our application architecture. We designed command and handler object to process business logic. To isolate the application layer from the rest of the project's components, we will use mocking methods at this stage. In the domain layer, we used the fake adapters approach in the previous video. You can access that video from the card at the top of the screen. To mock the domain layer, we must add the auto-configure mock MVC annotation above the class declaration and inject a command handler instance using the Mockito bean annotation. To define the mocking behavior, we need to create a before each method. Inside this method, define a create command object and set its fields. Since we will use these fields repeatedly in multiple test cases, define them as global objects. Now we are ready to define the mocking operation. When the command handler's save content method receives any create content command object, then it should return the command object. This is the mocking behavior of our command handler. Now we can focus on our test cases. We need a valid create content request object. To do this, we must define request and response classes. Go to the application package inside the src directory. Create the required DTO classes inside the request and response packages. Don't forget to define their fields. After that, turn to the test class and create a valid request object. This request will be processed in the application and will return a create content response wrapped in a response entity. Then we need to verify this response. Assert that the HTTP response status is 201 created. Assert that the response body is not null. Assert that the URL in the create content command matches the response URL. Assert that the creation time in the create content command matches the response creation time. This completes our successful scenario. The second scenario is a failure case. When we send a request with a null username, we expect a create content response from the application layer. However, this time its status must be 400 batch request first. Assert that the response is not null. Then assert its HTTP status. The third scenario is similar to the second one. This time we expect a 400 batch request when sending a request with a null text field. To execute our test case, we need to send the request to application. To achieve this, we will use TestRestTemplate. We send the request to the API v1 contents endpoint as an HTTP post request. We must also specify the expected response type. Since we will use this response type in other test methods, it is better to define it as a global object. Now, copy this line into the other test methods. At this point, we have completed the development of test cases. Now we can move on to developing the application layer. Before proceeding, we need to update our POM XML file. Update the Spring Boot Starter dependency to Spring Boot Starter Web dependency for REST communication. Add the Spring Boot Starter validation dependency to validate request fields. Next, navigate to the content create request class and add the not null annotation to the required fields. This ensures that every create content request is validated. If any field is null, the application will return a 400 batch request to the user. We need to define a REST endpoint to handle client requests. Create a new class named Content Controller in the API package. This class will process incoming requests. Then it will create a proper comment object and send it to the domain layer. Finally, it will generate a response based on the domain layer's output and return it to the client. Add the REST controller annotation to indicate that this class is a REST endpoint. Map requests to the controller's method using the request mapping annotation with an appropriate URL path. Define a method named createContent, which will return a createContent response wrapped in a response entity. Annotate this method with post mapping to handle post requests for the API v1 contents endpoint. This method must accept a createContent request as a parameter. Use the valid and request body annotation to validate and deserialize the request. When we run the application, Spring will capture every request and route it to the appropriate method. Annotations like request mapping, post mapping, and request body ensure that the request is properly processed. Since we have received a createContent request, we need to convert it into a createContent command so that it can be processed in the domain layer. To achieve this, create a new createContent command instance and set its fields. Then send this command to the domain layer. At this point, we need to invoke command handler. We should inject a command handler instance using constructor injection. Then we can call the saveContent method to process the command. At the end of this process, we will expect a createContent command response from the domain layer. The domain layer will process the command. If the request is valid, the domain layer will send the content to the persistence layer to create a record. We developed the persistence layer in a previous video. You can access that video using the card at the top of the screen. We need to return the domain layer's response to the client. Create a createContent response object and set its field using the response from the domain layer. Return a response entity with HTTP 201 created status, the createContent response as the response body. This completes the application layer's createContent behavior. Now we can run our test cases. Navigate to the test class and execute the tests. The creation operation has passed successfully. The read, update, and delete operations follow a similar approach. You can access all application layer tests and full implementation of all CRUD operations on the Tanhu Labs GitHub account. The link is provided in the video comments. In the next video, we will develop acceptance tests for the service content application using Cucumber. Subscribe to the Tanhu Labs channel for more content and don't forget to hit the like button. See you in the next video. Goodbye.